so that this is also made it possible the additional redundancy, sorry, the additional efficiency of the standard. Another technique which is new in the standard is the use of multiple antennas at the base station, the so-called multiple input single output MISO system. This is an evolution of the single frequency network architecture that solves some of the issues of the single frequency network while still allowing the use of the same infrastructure, the same antennas and the same planning as it was before. So and also doesn't require the change of the receiving devices, the rooftop, in particular the rooftop antenna. Constellation rotation, we will see this in detail in the following. This is a completely new technology that is useful especially in presence of error bus. A new synchronization scheme, synchronization block P1, we will describe again it in the following, that allows a fast acquisition of the DVB-T2 signal, so reduce the zapping time, the acquisition time, which was one of the critical issue in DVB-T. Okay, let's start with the system overview of DVB-T2. We will go through all these blocks in the following. We will start from the input, which is for us is a transport stream, so an MPEG transport stream, or a generic stream, which may be this new generic stream with encapsulation, or GSE, or a generic continuous stream, GCS, or generic fixed length packetized streams, GFPS. All these stream formats have been defined either for the previous generation of DVB-T, or they are new for DVB-T2 and S2, and allows more flexible handling of additional services that may be provided through the DVB-T2 standard. The output of the entire system is one or more signals that are going to be transmitted on one or more radio frequency channels. So we will now describe how to go from an MPEG stream to the signal to be transmitted on the RF channels. The main blocks of this process are an input preprocessor, input stream processor, bit interleaved coding module, frame mapper, and modulators. So the input preprocessor is something that is not defined by the standard and may be used to massage the stream before they enter the DVB-T2 system. So let's consider the input stream processor. It includes various sub-blocks. The purpose of the input stream processor is to translate the streams from the input, that are the transport streams or generic streams of the MPEG, to streams that may be used by the bit interleaved encoding module. We have different sub-blocks into this processor, that are the input interface, the CRC encoder, the baseband header insertion, padding insertion, and baseband scrambler. Overall, we can divide this block into two main sub-blocks, the mode adaptation and the stream adaptation. The mode adaptation has the purpose of generating baseband blocks. These baseband blocks are obtained by splitting the input sequence into blocks of the correct size, the data field length, whose maximum length is determined by the forward error correction scheme. So first of all, let's split the input into blocks that are of maximum length for the bit for the forward error correction. We have two possible input modes. One mode is where we have a single PLP. PLP means payload pipe, and is the generic stream that may be transmitted. In the BT2, it is possible to transmit on a single RF channel multiple PLPs. These multiple PLPs may include different services. For example, a PLP may be the video, another PLP may be the audio, but other PLPs may have different languages for the audio. A PLP may be used for the subtitling, and so on and so forth. So a single RF channel may include different PLPs, which is again payload pipes. So it's possible to have either one or single input mode, or either one of multiple PLPs. Mode A is referring to a case where we have a single PLP, and input mode B is referring to the case where we have multiple PLPs. The second block of the mode adaptation is the input stream synchronization. As we have seen, we may have different PLPs, but these PLPs might be somehow synchronized. It means that the receiver must be able to put on the same time scale different PLPs that may go through experience different delays in practice due to the way they are transmitted. We will see this in the following. So the input stream synchronizer insert a field, the input stream synchronization field, which comprises 2 or 3 bytes, that provide a general timestamp for all the PLPs that are processed by different mode adaptation and stream adaptation blocks in order to allow synchronization at the receiver. Then another action which is implemented by the mode adaptation block is the null packet detection, the deletion. In MPEG, it's possible to insert null packets that don't contain any data, but are inserted only to enforce constant bit rates of the transport stream input. Of course, these packets do not contain any data and are inefficient in terms of spectral efficiency. So as the BT2 is aimed at providing the highest spectral efficiency possible, these null packets are removed at the transmitter, signaled by a flag into the transmit stream, and so that it will be possible at the receiver to recover these null packets. So as you can see from the picture below here, we start from an input where we have different data packets, and some null packets. These null packets are removed, and the DNP deleted null packet bytes are inserted instead of the null packets. Fourth operation implemented by the mode adaptation block is the creation of a heading for the baseband block. This heading will include a 8-bit signal redundancy check (CRC) code, and also 10 bytes that describe the format of the data field, so they collect some information about the data field, including, for example, the size of the data field, which has been defined by the input interface. Now we are ready to go to the stream adaptation. The stream adaptation does something which is practice that actually modify the bits that are processed by the following model, and some other part of the operation made by the stream adaptation are not practice in terms of they don't modify the bits, but are that are meant to organize the further action of the modulation schemes.